Okay, in the last part, we will be finding derivative of this function using limit. So using limit only. If you study calculus in the past, you know how to use the shortcut to find derivative. Don't do it. When I say use limit, then you are only allowed to use limit. So that is the limit definition right there. So in part A, I have a function right there. So we have to start with f prime of A. So that equals to limit of a function. So we have h goes to 0. So for the top, we have a plus h. So you have to replace the x with a plus h. So 2 times x plus h, use parenthesis, plus 1 divided by x plus h plus 3. And then subtract f of a, which is just the function, which is 2x plus 1 divided by x plus 3 divided by h. You have to do some crazy algebra on top in order to get rid of the h in the bottom. So for the h, I am going to pull the h out. So divided by h, right? So that means we have a big 1 plus h right here. And then the top, I will get a common denominator. So the common denominator is, oh, by the way, I use a plus h, right? So a and then a. So the common denominator is a plus h plus 3 times x minus 3. So for the first numerator, I am looking for x plus 3. So that will be a 2a plus 2h plus 1 times x plus 3. And then this is a 2x minus plus 1. I am looking for a plus h plus 3. a plus h plus 3. In case you are wondering, hey, how come the h just got over there? So let me give you a quick simple example. So let's say you have 1 divided by 2. You divide the whole thing by 3 in a complex fraction. So it is okay to pull the 1 over 3 out, right? And then you multiply 1 divided by 2. Right? That is the same thing. So that's why I can pull the h out like that, because I don't want to keep writing a complex fraction. So go back to the problem. First, we have to fully expand everything on top. So we have limit as h goes to 0. There is, you can't plug in yet. Once you plug in 0, then you have a 0 in the denominator. So you fully open up the top. Wow, this is long. So you have 2a times x, 2a times 3, so on and so forth. So you have 2ax. I keep writing x. So let me fix this. I use a, right? So I have to replace the x with a, x with a. So this is a, and then this is a. I keep writing x. Did I fix all of them? Nope. This one needs to be fixed. So no x, a only. So we have 2a times a. Then that will be a 2a squared. And then 6a plus 2ah. And then plus 6h. Do it slow, because it is easy to make mistakes right here. Plus a plus 3. And then this, if you don't want to take care of the minus, just use parentheses. 2a squared plus 2ah plus 6a, and then plus a plus h plus 3. All right, and then the denominator, don't touch it, just copy it. A minus 3. Okay, so we are going to open up the minus, and then to see if we are able to get rid of any term. So we have limit as h goes to 0, 1 divided by h. Keep the line straight. We have 2a squared plus 6a plus 2ah plus 6h plus a plus 3 minus 2a squared minus 2ah minus 6a minus a minus h minus 3. All right, divided by a plus h plus 3, and then a minus 3. And then we try to do some cancellation. I can see that the 3 and the 3 is cancelled. The a and the a minus a and plus a, they are cancelled. The 6a and 6 minus 6a, the 6a and the minus 6a. And then what about the 2ah? the 2AH, and the 2AH. Anything else? So we have 2A square. Oh, hold on. The 2A square can be cancelled. So this 2A square and this 2A square. So we only have a 6H left. Actually, it's a 6H. So let's change the color a little bit. It's a 6H. It's hard to see. Which color should I use? So we left with a 6H and a minus H. And then we continue. So the next step, we have limit as H goes to 0, 1 divided by H times 6 minus 1 is 5 times H, right? Divided by A plus H plus 3, and then A minus 3. So we are going to get rid of H right now. So you get rid of this H and that H. So now we are safe to plug in 0. So even though H goes to 0, you have a A times 3. Is that a plus or a minus? Hold on. This is a plus. A plus. So that will be a plus. This will be a plus. And then this is a plus. This is a plus. So when you plug in H, you have a A5 divided by A plus 3 square. So that would be the slope. This, what is this called? This is called the slope of the tangent line. Slope only. We don't have any equation at this point. The slope of the tangent line to the function, the given function, at x equals to a. So the function is a curve going up and down, up and down. And then you pick a point. All right, I pick any point, x equals to a. I'm not giving you any value. So when x equals to a, can you tell me what the slope is? Yes, the slope is right here. This is the slope. Right here. So that is my slope when x is equals to a at any a value. So if you want a to be -1, then you plug in a -1. If you want a to be 0, then you plug in a 0. If you want a to be a 10, then you plug in a 10. Plug in anything you like. But you pick an a, that a must be in the domain of the function because the function is a rational function, right? So for example, in this function, you don't want to plug in a -3 because look at the given function. If you plug in a -3, the function itself is already undefined. So and undefined, there is no slope over there. So you cannot plug in x equals to -3. So this is a means any x value, but that x value must be in the domain of the given function. All right. So let's take a look at a square root. Change colors for that. So in the next problem, we have a square root. We have b. We have f of x equals to the square root of 1 minus 2x. So we are looking for the slope f prime of a that equals to limit as h goes to 0. We have f of a plus h minus f of a. I'm going to watch myself, so I'm not going to keep using x. So we have limit as h goes to 0. All right, so this is 1 divided by 2 times a plus h, and then minus the square root of 1 minus 2a divided by h. So we have a square root. To do some simplification, I need to multiply by a conjugate. This is a minus, so I have to multiply the entire function by the square root of 1 minus 2a plus h. So the opposite of minus is a plus. 1 minus 2a, and then you write the same thing in the denominator. Okay, and then you open up the top. What do I mean by open? Open up means you have to multiply like this. Just like how you multiply x plus y and then x minus y. Okay, don't just multiply y and x. All right, you have to fully open up the whole thing. So what do you get? So when you open it up, always start with a limit. H goes to 0. So square root times itself, and then the square root is gone. 1 minus 2 times a plus h, and then you look at the plus or minus. You have a plus, and then you have a minus. So the two terms in the middle will be cancelled. Just like when you open up this x plus y, you have a minus xy plus xy. So the minus and the plus, they got cancelled. And then minus y squared, right? So basically you square the other square root, so that becomes 1 minus 2a, and then the denominator, don't touch the denominator. Whatever it is, just put it down. Don't open up or don't simplify anything. 1 minus 2 times a plus h plus the square root of 1 minus 2a. Oh, actually, this we only need to close the denominator, right? Okay, so the top, what do you have? You have 1 minus 2a minus 2h minus 1 plus 2a. So the minus and the plus, they are cancelled. The 1 and the minus 1, they are cancelled, right? So we only have a negative 2h on top. So that is enough to get rid of the h in the denominator. 1 minus 2 times a plus h plus the square root of 1 minus 2a. And then we get rid of the h. You must get rid of the h. You did all the algebra and you still cannot get rid of the h. That means your work is wrong. If you are unable to get rid of the h, your work is wrong. If you make one little mistake in that crazy algebra process, then the whole thing is wrong. You won't be able to get rid of the h if you make one tiny little mistake. Alright, so our biggest enemy is eliminated. Let's just plug in a 0. So we plug in a 0. What do we have? We plug in a 0 to here, right? So that means we have negative 2 divided by the square root of 1 minus 2a, and then plus 1 minus 2a. So you have 2 of those in the denominator, right? And then you get rid of the 2, you have a negative 1 divided by the square root of 1 minus 2a. 2a. What is this called? This is the slope of the tangent line. So this answer is called the slope of the tangent line to function f at x equals to a. So the function is a square root, right? So that is a curve. And then you pick a point. You want me to give you the slope? Yes, I can give you the slope. The slope is negative 1 divided by the square root of 1 minus 2a. I don't have a value of a right now because you have to let me know what a is. So if you let a be negative 5, okay, you plug in a negative 5, then I can give you the slope. So this is the slope at any point. But when you pick an a, that must be within the domain of the function. So that means you plug in an a, you pick an a, you plug in the function must be defined. If the function is not even defined for the a value, then there is no slope then. So since we have a square root, then you can specify that 1 minus 2a must be greater than 0, and then you can solve for a, right? So you have 1 greater than 2a, and then 1/2 is greater than a. So that means a must be less than 1/2. When you choose a value of a must be less than 1/2. Alright, so let's say you choose a 10. 10 is not less than 1/2, right? You plug in a 10, then you have a negative inside a square root that makes the whole thing undefined. Alright, so that will be all in this section. I will see you all in the future videos.